Number one, the velocity of a particle moving in a straight line at time t seconds after leaving a fixed point O is v meter per second. The diagram shows a velocity times graph which models the motion of the particle from t equals 0 to t equals t, from this point to this point. The graph consists of 4 straight line segments, 1, 2, 3, 4. The particle accelerates from rest to a speed of v meter per second over a period of 4 seconds and then decelerates at 5/3 meter per second squared to instantaneous rest over a period of 6 seconds. The particle then travels back towards O, reaching a maximum speed of 3 meters per second before coming to rest at time t equals t. Find the value of v. We have information that deceleration equal 5/3 minus is sign of deceleration, meter per second squared. T or time equals 6 seconds, and the final velocity equals 0, and the initial velocity equal v. So using the formula that final velocity equal initial velocity times at is 0, v plus minus 5/3 times 6. Okay, so it becomes 0 equal v minus 10. So it means v equal 10 meters per second. Next question B. Given that the total distance traveled by the particle from t equals 0 to t equals t is 68 meters, find the value of t. According to this information, that the distance from this point to this point is 68. Now we are going to find distance from this point to this point to 10. So it means we will calculate the area of this triangle. From part A, we have information that v equals 10. So this is 10. And area of this triangle, or distance from 0 to 10, equal 1/2 times 10 times 10. And it is 50. So 50 meters from 0 to this point. If 10 to t is x, okay, so we can find the distance from 10 to t with base x. X is 68 minus 50 equal 18. So this is 18. Now we are going to find the distance. Distance is area of the triangle. The second distance, so the time, I mean, not distance. Distance is 10, but time, what's that, minus time, okay, 1/2 times 3 times x, 68 minus 50. So this is 3/2 x for 18. So x equal 12 because 18 times 2/3. So this is x. Sorry, actually this x equal 12. This is x for the calculation. So actually 12. So the time from, I mean x time from 10 to t, okay, the time is 12. So the time. So the total time, n plus 12, 22 seconds. Next question. A block of mass 20 kg is held at rest at the top of a plane inclined at 30 degrees to the horizontal. The block is projected with speed 5 meters per second down a line of greatest slope of the plane. There is a resistance force acting on the block. As the block moves 2 meters down the plane from its point of projection, the work done against this resistance force is 50 joules. Find the speed of the block when it has moved 2 meters down the plane. Using the work done energy principle, I would like to write in the formula to gain the final kinetic energy, that the initial kinetic energy plus work done by gravitational force minus work done against resistance equal final the final kinetic energy. We call it final kinetic energy. Right. Now we are going to find this part. The initial kinetic energy is 1/2 mv squared, or mu, initial velocity mu squared. So this is 1/2 times 20 times 5 squared. It is 250 joule. After that, the kinetic energy final, this one, that is 1/2 mv squared, so 1/2 times 20 v squared. So it is 10 v squared. We're going to find v. Work done by the gravity is mg sine theta times s. Okay, so 20 times 9.8, the gravitational force, sine 30 times 2. So it becomes, if you calculate, 196 joule. Now that work done against resistance, that is W resistance, and this is based on the information, this is 50 joules. 50 joule is energy loss. Right. So from this formula, you can determine phi becomes 250 joule plus 196 joule, 50 joule squared. If you calculate 10 phi squared equal 396. So phi squared equal 39.6, or this is 40. So phi equals square root 40. It is 6.32 meter per second. Number 3, a cyclist are riding along a straight horizontal road. The total mass of the cyclist and his bicycle is 90 kg. The power exerted by the cyclist is 250 watts at an instant when the cyclist's speed is 5 meters per second. His acceleration is 0.1 meter per second squared. Find the value of the constant resistance to motion acting on the cyclist. To find the constant resistance to motion, we can use the relationship between power, force, and velocity along with the Newton's second laws. So the net force accelerating on the cyclist, net force m times a. So this is 90 times 0.1 becomes 9 newtons. Let net force equal drive force minus resistance force. Okay, this is resistance. Now we're going to find F drive for drive force using this for a power equal drive force sorry times phi. So it becomes arrange this formula P over phi. So drive force for 250 divided by 5, 50 Newton. So this is 50 Newton. So if we substitute F net equal, this is 9 and this is 50. So this equation becomes 9 equal 50 minus F resistance force. So the resistance force equal 50 minus 9, and it is 41 Newton. Next question. The cyclist comes to the bottom of a hill inclined at 2 degrees to the horizontal. Given that the power and the resistance to motion are unchanged, find the steady speed which the cyclist could maintain when riding up the hill. Okay, so the component of weight downslope, gravitational force equal mg sine theta. So it becomes 90 times 9.8 sine 2. So if you calculate, the result is 30.78 Newton. And after that, if you sketch this condition, you can find the total opposing force. The total opposing force, I would like to using F total, 41 plus 30.78, and it is 71.78 newtons. And after that, we're going to find the steady speed. The steady speed, we will using the formula P equal F times P, or phi equal P divided by F. So this is 250 divided by 71.78. And the result is 3.48 meters per second. Number 4. This diagram shows two particles A and B of masses 0.2 kg and 0.1 kg respectively. The particles are suspended below a horizontal ceiling by two strings, AP and BQ, attached to fixed points P and Q on the ceiling. The particles are connected by a horizontal string AB. Angle APQ equal 45 degrees and angle BQP equal theta degrees. So on and this one. Its string is like and inextensible. the particles are in equilibrium. Okay, so this particle A and B are in equilibrium position. Find the value of the tension in the string AB. So we're going to find the tension AB in tension AB. So between A and B, acting two forces to the right and to the left. And several forces acting on this uh, particle. Okay, first this is m times g, to downwards. Okay, mass times g, 0.2 times 9.8. And after that, based on this information that are in equilibrium, it means there are also force acting on this particle A. Okay, for example, if this is Y. So if this is this tension AP, so we're gonna find Y if there is a right angle like this, a right angle triangle, and if there is to the left, this is the tension AP cosine 45 degrees. So this is 45. This angle as well 45 degrees. Right. So if this is y, so we can find that y equal sine 45. The sine 45 equal y over tension AP. So y equal tension AP sine 45. So this is tension AP, tension AP sine 45. But we are going to concern to tension AB. So through this information, this diagram, we can state that the tension AB sine 45 equal m times g cosine 45. Okay, so tension AB, this is square root 2 over 2, and m is 0.2 based on this information times 9.8, the gravitational force, and cosine 45 equal to half, like this. So we can determine tension AB equal, if 0.2 times 9.8, this is 1.96 times square root 2 half divided by square root 2 half. So it is 1.96, or it is 2 newtons. So tension AB equals 2 newtons. Next question. Find the value of theta and the tension in string BQ. Right. Back to the diagram. This is BQ. I'm going to clean this area. Right. So I would like to create the new line here. Okay. This is the tension BQ cosine theta. Right. Tension BQ cosine theta, cosine 45. Okay. Cosine 45. This is theta here. So this is tension BQ, And I would like to create the right angle triangle here for PQ. Like this. We'll expand the uh, triangle. This is theta here, and this is 0.1 based on the information 0.1 kilograms. So uh, we can determine that tangent first tension BQ first tension BQ squared equal m times g squared plus the tension AB squared. Okay, so tension BQ equal this is mg is one. This is tension AB. So the tension BQ you can find through this is 0.1 times g here because m times g times 9.8. Then this one is 2 square based on the previous information. So it becomes 0.96 plus 4. This is square root 5 because 4.96 round off becomes 5. So it is 2.24. So theta, tangent theta is 0.1 times 9.8 over tension BQ based on this 2 point tension BQ. Okay, you got 2.24. And if you calculate this is 0.49. Based on the information, this is 0.49. So theta we can determine through tangent 1 of 0.51. This is 26.565. Okay, 6.6. That is theta, and this one the tension of BQ. Next question. So particles P and Q of masses 2 meters kilogram, 2 m kg and m kilogram respectively are held at rest in the same vertical line. The height of P and Q above horizontal ground are 1 meters and 2 meters respectively. P is projected vertically upwards with speed 2 meters per second at the same instant. Q is released from rest. Okay, find the speed of each particle immediately before they collide. Okay, the positions of these particles of two particles first, according to this information that there are uh, particles Q, okay, with mass m kilograms and another particles P here with mass 2 kilograms, and the distance between P and Q is 1 meters, and between particle P and ground also 1 meters. Okay, based on this information, right? And after that, this particle P, is it has speed, okay, or 2 meters per second to upwards, and this particle Q, has velocity or speed to downwards. Okay, so we are going to find the distance. Okay, okay, find the speed. Okay, find the speed. But first, we need to find the distance. So SP, we are going to using the formula S equal ut plus 1/2 at squared. This is the initial velocity and its acceleration. We are going to using gravitational force 9.8, right? So SP equal t minus 1/2 dt squared. Why minus? Because this is to upwards. So it's going to be the initial is 2, okay, 2t minus 1/2 uh, times 9.8 t squared becomes to t. Actually, this is 4.9, but I would like to round becomes 5t squared. So this is the SP. And after that, for Q, Q is UT plus because it's towards downwards, and then 1/2 dt squared. So this is from the rest, it means this is equal 0. So it's going to be 0 plus 1/2 dt squared times 9.8. This one is 9.8 or 9.8, 4.9. It becomes 5t squared. All right. P and Q at the same distance when P and Q at the same distance from the ground when they were collide. That's the information. So we can state that 1 plus this one s is the distance equal to minus s t based on their condition. So it means 1 plus this one sp 2t minus 5t squared, 2 minus 1 sq for 5t squared becomes 0. And you can determine 2t, or you can determine t to 2 minus 1. So it means t, this is 1, t equal 1/2. So using the formula that v equal the final velocity equal initial velocity plus at. So it means the velocity or speed of p equal the initial velocity is 2 minus 10 times 1/2 because t equals 1/2. So it becomes 2 minus 5 minus 3. But velocity never negative. So the speed the speed of p, or the speed of p before collide is 3 meter per second. This is before collide. Again, this is the velocity of particle p before collide. Now we're going to find the velocity of particle q before collide. So the velocity or the speed or of the particle Q before collide is 0 plus 10 times 1/2. So it is 5 meters per second. So this is the velocity or the speed of particle Q before collide. It is given that immediately after the collision, the downward speed of Q is 3.5 meters per second. Find the speed of P at the instant that it reaches the ground. We will using the rules or the theory or the formula about momentum, momentum before collision and momentum after collision. Momentum before collisions equal the momentum after collision. So momentum before equal momentum after. Okay, momentum before collision equal momentum after collision, and the formula is mp times. I would like using P1. It is P1. It means before collision, and Q times phi Q1 equal MP PP2. PP2 it means after collision, and Q PQ2. Q2 it means after collision. Right. So this is 2M, and this one is 3, and Q is N, 1N, and this is 5, and this one is 2M. Okay, it is phi P2. We are going to find the velocity of particle P after collision, and this is MQ is N, and this is 3.5 based on this information. All right, so this is 6 plus 5, 11M, equal, this is 2M P2 plus 3.5M. Now left-hand side and right-hand side divided by M. So it's going to be 11 equal 2 phi P2 plus 3.5. And then 2 phi P2 equal 11 minus 3.5. So phi P2 equal, this is 7.5. 7.5 divided by 2. It is 3.75 meters per second. So the velocity particle P after collision is this one, 3.75. Now the height. The height of P above the ground equal 1 plus the distance of P. So 1 plus 2t minus 5t squared. We got this information from part A, the previous part. So it's going to be 1 plus 2 times 1/2, because t is 1/2 minus 5 times 1/2 squared. And if you calculate, the result is 3/4 or 0.75 meters. Number 6. A particle P travels in a straight line starting from a point O with velocity 6 meters per second. The acceleration of P at time t second after leaving O is a meter per second squared, where A equal minus 1.53 power 1 half for t interval 0 to 1. And acceleration function will be 1.53 power 1 half minus 3t to the power minus 1 half for t greater than 1. Find the velocity of p at t equal 1. At t equal 1, it means we're going to using this function because t equal 1. T on this interval, right? So given that this is the function and the interval, this is the initial velocity. The initial velocity is 6 meters per second, according to this information. And then the acceleration function, this one minus 1.5 to the power 1 half. To find the velocity at t equal 1, we need to integrate the accelerations from t equals 0 to t equal 1, 0 to 1, based on this interval. Now, integrate acceleration to get the change in velocity, that Vt equal v equal initial velocity times integral 0 to 1 of this one minus 1.5 t power 1 half dt. The initial velocity is 6 plus integral 0 to 1. The integral of this function is minus 1.5 times 2/3 t to the power 3 half. And this becomes 6 minus, if you calculate minus 1.5 and 2/3 becomes t power 3 half. Okay, but we are going to substitute 1 and 0. So it's going to be 6 minus 1 plus 1 power 3 half. If 0 is still 0, so it is 5 meters per second. Next question B. Given that there is no change in velocity of p when t equal 1, find an expression for the velocity of p for t greater than 1. For t greater than 1, according to this information, we are going to using this function, this acceleration. Okay. So to find the velocity, we are going to integrate the acceleration. So Vt integral at or integral 1.5 t power 1 half minus 3 t power minus 1 half dt. So it becomes, if we integrate this expression becomes t to the power 3 half minus 6 t to the power 1 half plus c. Now, when t equal 1, v1 we are going to using this expression 1 power 3 half minus 6 times 1 power 1 half plus c, and according to the information that v1 equal 5. So it becomes 1 minus 6 plus c equal 5. So we can state that C equal 5 plus 5, 10. So it means phi t, the function phi t equal 3 power t power 3 half minus 6 t power 1 half plus c equal 10, so plus 10. Let's move to the next question. Given that the velocity of p is positive for t less than or equal 4, find the total distance level between t equal 0 and t equal 4. Okay, so total distance 0 to 4 of t. But I will split becomes two intervals, 0 to 1 and 1 to 4, right? First, from t equals 0 to t equal 1. The function is minus t power 3 half plus 6, or 6 minus t power 3 half, but I would like to using this expression. Okay, so integral 0 to 1 minus t power 3 half plus 6 dt. The integral of this expression is 2/5 t power 5 half, okay, 6t. Now that substitutes 1 and 0. But I would like only substitute 1 because if 0, all of this becomes 0. So minus, so this is minus actually, minus 2/5, 1 power 5 half plus 6 times 1. It becomes, if you calculate all, it is 28 over 5. And next from 1 to 4, the interval. From 1 to 4, the function phi t power 3 half minus 6 t to the power 1 half plus 10. This is the function. So integral 1 to 4 of this function, t to the power 3 half minus 6t to the power 1 half plus 10 dt. We're going to find the integral of this expression, and the integral is 2/5 t to the power 5 half minus 6 times 2/3 t to the power 3 half plus 10 t. So it becomes substitute 4 and substitute 1. 2/5 times 4 power 5 half, 4, because 6 times 2/3 equal 4. 3 half and times 4 minus substitute 1, fifth, 1, 4 times 1 power 3 half, 10 times 1. Okay. And if you calculate this, is 62 over 5 minus 28 plus 30. 30 because 40 minus 10. So it's going to be 62.5. This is plus 2, 72.5. The total distance for 38 over 5 plus 72.5 is 100. 5, it is 20 meters. So this is the total distance. Number 7, look this diagram. A question. Two particles A and B of masses 0.2 kilograms and 0.3 kilograms respectively are attached to the ends of a light inextensible string. The string passes over a small fixed smooth poly which is attached to the bottom of a rough plane inclined at an angle theta to the horizontal where sine theta equals 0.6. Okay, sine theta 0.6, it means if sine theta, I would like to find cosine theta. Okay, if it means this is 8, right? So if sine theta equal 6 over 10, 0.6, it means cosine theta 8 over 10, 0.8. Particle A lies on the plane and particle B hangs vertically below the poly 0.25 meters above horizontal ground. The string between A and the poly is parallel to a line of greater slope of the plane. Look at the diagrams. The coefficient of friction between A and the plane is 1.125. It means this is mu. Particle A is released from rest, right? I would like to show you uh, the forces acting on this particle and this particle A and B. The first is one. This is m times g, or 0.2 times. I would like to using the gravitational force 10, and then there is a force. This is a force of m times g cosine theta. Okay, so 0.2 times 10 times 0.8. So, and it's same with the resonant, the R. R is mg cosine theta. So it is 0.2 times 10 times cosine theta 0.8. Okay, 0.8. So if you calculate this is 0.2 times 0. Wait, I will calculate 0.2 times 10 times 0.8. It is 1.6. Okay, so it is 1.6, right? And uh, there is a force here. This is F. Okay, F is mu times R. Okay, and mu is 1.125. Just now we have information from this one. This is mu 1.125 times R is 1.6. Okay, so F equal 1.8 newtons. And then there is a force here to this is the string. So the string occurs on this the tension occurs on the string as well, on this string, and they have different direction to upward and this to downward. But there is a force to downwards acting on this particle, and that is 0.2 times G sine theta. So this 0.2 times 10 times sine theta 0.6. I would like to multiply 0.2 times 10 times 0.6, 1.2. So this is 1.2 newtons. Right. So look this on this particle. So I would like to writing the equation on the particle A is 0.2 times G sine theta plus tension minus F equals 0.2A based on this information. So by this 0.2 G sine theta to downwards plus tension uh, minus F, okay, this is the function, the force acting to the different direction with to downwards to upwards. Okay. And after that, on this particle, there is a force M times G acting, or 0.3 times 10. Yeah. So the equation on part B, equation on part B is 0.3 times G minus T equals 0.3A. Now, from particle A equation, I would like to simplify. It becomes, this is T plus 1.2 because this is 1.2. Okay, we already calculate minus F 0.2A. Okay, so T equals 0.2A minus 1.2 plus 1.8. Just now we already calculate that F equal 1.8. So it means T equals 0.2A plus 0.6. This is the first equation. Next, from particle B, from this one, we are going to simplify this equation. So 0.3 G minus T equal 0.3A. So it becomes T equal 0.3 times 10 and 0.3A. This one. So it is 3. It means 3 minus 0.3A. That's the equation. Now, equating this equation and this equation. So if we equating, it becomes 0.2A plus 0.6, 3 minus 0.3A. So it's going to be 0.5A. 3 minus 0.6 becomes 0.5A, 2.4. Okay, so A equal 2.4 divided by 0.5. And it is 4.8 meter per second squared. And this result, A equal 4.8, substitute into this equation, T equal 3 minus 0.3A, and we can gain T 3 minus 0.3 times 4.8 And if you calculate, the result is 1.56 Newton. So T equals 1 and A equals 1. Let's continue to question B. When B reaches the ground, it comes to rest. It comes to rest, it means the velocity becomes zero. So find the total distance that it travels down the plane from when it is released until it comes to rest. You may assume that A does not reach the valley. Okay. So first, I would like to find phi squared, the velocity based on the kinematic equation. Phi squared equal u squared plus 2as. In this case, the initial velocity equals 0. Okay, 2 times a, just now we already calculate 4.8, and s 0.25. 0.25 from the question just now, mistaken here, so this one, 0.25. So it means phi squared equal 2.4. And after that, we are going to using the energy theorem, that the total work done equal the initial kinetic energy, the initial kinetic energy of particle A at moment particle B hits the ground, minus the total work done, against friction and the gravitational force and gravitational, it's equal to 0. So this part minus this part is equal 0, because it hits the ground, comes to rest, equals 0. So now I would like to write in the formula becomes 1/2 the initial kinetic energy of A at moment B hits the ground. It is 1/2 times 0.2 times phi squared, from 1 plus 0.2 times g sine theta, times d, times d minus, so this part is 1, minus total work done, this one, mu times 0.2 times g cosine theta times d, it equals 0. And from this part, okay, it is 0.24. Just now we already calculate this one, the phi squared, this one, calculate, plus 1.2, this one, 1.2, to calculate d, minus this is, mu is 1.125 times 0.2 times 10, okay, times 0.8 d, 0. So it becomes 0.24 plus 1.2 d. If you calculate this part, 1.8 d equals 0. 0.24, this is minus 0.6 d equals 0. So it means 0.6 d equals 0.24. So it means D equals 0.24 divided by 0.6, and it is 0.4. So D equal 0.4 meters. So the distance A moves while B falls is 0.25 meters. And distance A continues to upward before before stopping. It is 0.4 meters. So the total the total distance the total distance travel of A is 0.4 as 0.25 plus 0.4. So 0.65 meters. Sorry.